for joining us today. I'm Jesse Berst. I'm your host and moderator today, and we're here to talk about integrated network operating centers. You know, as I travel around and talk to utilities around the country, one of their top wishes is this INOC, Integrated Network Operating Center idea. They don't want a bevy of standalone tools. They don't want to be re-entering information. They don't want to use what I call the swivel chair interface. In addition, when you start using the communications network for smart metering, for distribution, automation, etc., it becomes mission critical. And then it has to be maintained with the same rigor, the same 24/7, always-on mentality as the grid itself. And that leads to this strong drive to create an integrated network operating center. But that's a very complex topic. How do you get there? Where do you start? What issues may confront you along the way? Those are the questions we're going to answer today with the help of two experts, and you see their faces on your screen. So I'll introduce each of them in a little more detail when it's their turn to speak. But very quickly, we're joined by Karen Lefkowitz. She's the VP of Business Transformation at PEPCO. Karen, thanks for joining us today.
Thanks for having me, Jesse.
And also with us is Vaibhav Parmar. He's the Global Lead for Wireless Network Consulting at Accenture. And Vaibhav, welcome.
Pleasure to be here, Jesse. Thank you.
Now, all three of us have put up our contact information on the last slide at the end of the presentation should you want to reach any of us directly. So here's what we're going to cover today. I want to talk just to set the context with the help of Vaibhav about what some of the basic utility communications requirements and issues. We'll define an INOC and its purpose, and then we'll talk about some of the costs and the benefits, the challenges, and the components of an integrated network operating center. Then the second half, we're going to turn our attention to PEPCO's process, what happened when they start marching down this path, and some of the lessons that they learned, some of the things that you'll want to understand if you're about to embark on this journey yourself. So I'm very happy to welcome Vaibhav Parmar. He is the Global Lead for Wireless Network Consulting at Accenture. He's got an extensive background in mobility services. He's a frequent speaker at industry events, and he's got a master's in electric engineering. So it's not an exaggeration to say that he's one of the world's top experts in this topic, and we're lucky to have him along today. So Vaibhav, over to you.
Great. Thank you, Jesse. Good morning, good afternoon, good evening, everybody. Thank you for joining this webinar today. As Jesse mentioned, this topic of the Integrated Network Operations Center is really becoming an important topic and certainly a hot topic in the utility industry for a variety of reasons. And for the first part of this webinar, I'll talk about what those reasons are and what's happening in the utility industry that's causing this concept or this idea of an integrated operations center to become more and more prevalent, and certainly what the reasons are for utilities embarking down the path to building these environments up. The primary driver behind this, and you can imagine, with the sophistication and automation that's happening in the transmission and the distribution world, and then initiatives such as smart metering and the variety of things that take place in the smart grid domain, the amount of technology that's being put in, the amount of automation and sophistication that's being put in requires a lot of complex engineering. A lot of this engineering is very similar to what has taken place in the IT world when advanced LAN and WAN networks have been deployed, when advanced telephony systems and email systems have been deployed. But I think there are some unique things that are happening in the transmission and distribution world that really are causing the Integrated Operations Center or the Integrated Network Operations Center to become an important topic and certainly an agenda for both the CIO and the power delivery or the power engineering side of the house. The primary premise or the key theme that I want to focus on are really around the communications technologies and the computing technologies that play a role in the new T&D world and why that is a driver for the INOC. As you can see on this slide, the needs of the utility from a communications network perspective are evolving and are certainly becoming more stringent and diverse than before. Certainly coverage is one of the primary drivers, and the coverage needs have always been there, certainly with the field technicians and the service technicians that have jobs that they need to do in places where there may not be any humans or buildings. Coverage needs have always been there. reliability is becoming more and more important, certainly as more devices, intelligent devices are being deployed into the field. The need to stay connected to them and the need to have higher reliability is more and more important. The variety of devices is becoming quite diverse. It's no longer just a type of an RTU that needs connectivity. Now we've got connectivity needs going out to all sorts of endpoint devices that have very different usage patterns and have very different communications patterns. And then with that, you've got different priorities that go with it. So as you put all of this together, you can start to see that the communications network environment of the utility is becoming more and more complex. Historically, there have been systems that have been deployed that have been very single purpose, were unique to a particular type of a use case or a connectivity scenario. Now the desire is we want to use as many common systems as possible. Although this chart is quite a bit of an eyesore here, the point that we wanted to make is as you start working from the bottom and going upwards, you can see that the types of environments and the types of devices that require connectivity is quite broad. If you look at a truly vertically integrated utility that has generation, transmission, distribution, the retail business, and then certainly the corporate and the enterprise business, and if the utility has a combination of both gas and electric businesses, you can only imagine how diverse its needs are from a coverage point of view, from the types of devices that need connectivity point of view. And because of that, you can start to see that there will be a variety of different network systems that will play a role in interconnecting all of these devices, interconnecting all of these endpoint environments. While no one network will meet the communications needs, we'll start to see that there will be a series of networks or a common set of networks that will play a role. And you can see in this chart that we're envisioning some type of a set of field area or edge area networks that will be somewhat unique to the endpoint environment, but they'll all have common connectivity to some type of a larger core network that may be supported through some common set of technologies such as fiber optics or microwave or whatever it may be. The reason I wanted to present this slide is because it's no longer the norm that the utility is able to just have basic network engineers in its environment and in its staff to keep the stuff running or to even architect the stuff. I think as you can see the complexity from the previous chart, it becomes more and more important that the utility actually maintain a full life cycle of skills and capabilities to architect, engineer, deploy, and operate these systems. And you can see here that it's not a trivial exercise. Even just the planning and engineering part of this environment takes a lot of sophistication. You've got to have people that understand supply chain and procurement, people that understand how to do proper network and capacity forecasting. We've got these talents in-house already. We certainly do that on the IT side with the LAN and the WAN environments. But as we start putting these networks out into the field and as we start using more and more sophisticated networks and IP-based networks, these skills and these requirements become more and more prevalent. The one specific area that I wanted to focus on today is the third area here on the right side of the slide, which is around network operations and management. And our premise here is it's no longer just important to engineer and deploy these types of sophisticated networks. Once they're deployed, we've got to have the right types of tools, systems, and people in place to be able to run and manage them. If these things can't run, we're not going to be able to deliver to the expectations of the business, and we won't be able to commit to the SLAs that the business and the applications ask for. So the need for network operations, the need for infrastructure operations becomes very critical. So let's talk about the integrated network operations. What is that and why is that important? The basic definition from our perspective is it's the ongoing process of monitoring, managing, and reporting on smart grid, smart metering, communications network, and IT infrastructure that supports all the different types of business services that make up the utility landscape. So an example would be, let's look at the meter-to-cash process. What are all of the technological elements that play a role in delivering the meter-to-cash service? The premise behind the Integrated Operations Center or the Integrated Network Operations Center is this is the environment that will have end-to-end visibility of that entire service, and we'll be able to look at the service be able to decompose a service into individual elements and help figure out when there's a problem, when there's a performance issue, what is the root cause of that issue. Today we manage all of this infrastructure in somewhat of a singular manner, and it becomes difficult to be able to correlate the state of the technology from a metering point of view versus the state of the technology from an IT or a data center point of view. When we're able to correlate across all these domains, we're able to have a lot more efficiency. We're able to manage to SLAs much more better than previously, and I'll talk more about that as we keep going. So what are the key trends of an INOC? Our perspective on the INOC and the key elements or the trends that make up a high-performance INOC are, it is the environment in which we've got consolidated operations, and again, with a focus on service management. And this is a critical point here in the definition because, again, today we manage our different environments, and we've gotten quite advanced and mature in that. We've got sophisticated tools to manage our data center systems. We've got sophisticated tools to manage our telecom systems. But again, the INOC is the environment in which we're able to get a service-centric view and able to manage everything at the service level. It is, some of the other trends that make up the INOC are more efficient processes and increased skill sets of the personnel. We're able to automate the operations, and certainly with the focus on productivity. It's an environment where we've got much more greater integration in how tools and systems are being used, and I'll talk a little bit more about that in a few minutes. And then we focus on performance and applications monitoring. Again, historically, when we talk about an operations or a management environment, we think about, kind of a different set of monitors where we've got red, green, yellow alarms coming in, and we've got eyes on those screens that are able to decipher those alarms and do something behind it. The next layer of sophistication to that is really using automated technologies to figure out, well, what do those red, yellow, greens mean? And can we automate some of that activity that typically the eyes on glass would perform? And now there's been enough of a track record in understanding these systems and technologies that we can create automated correlation logic and focus more on performance as opposed to individual faults. So again, if you think about these key trends, if you think about, well, what is a lead up into the INOC, and the key drivers being a variety of intelligent devices, a variety of communications networks that interconnect all of these devices, and most importantly, these devices and these networks playing a role in delivering critical business services, we want to focus on the service. We want to focus on what is important to the business and use these technologies that are in the INOC to figure out how do we look at the service from a beginning to end perspective and then decompose that into the individual elements, which we're then able to manage in a business as usual manner. So with that, I think, Jesse, at this point we're going to pause to see if there are any questions out there.